What's up, everybody? Today, I'm going to be talking about combining radicals, and I'm going to show you guys exactly how to do that. So, number one, right? The biggest thing that we have to understand is that when there is no number in the root, we should always know and assume that it is 2. And for us to combine radicals, two things must be true. One, they have to have the same root. All right. So if these two numbers in blue or these two radicals in blue had a root of 3, we could add and subtract them or 2. And also the number under the radical as well. They have to have the same root and the same number under the radical. And once they do, we treat the radical like a variable, meaning we're not going to do anything with it. We're just going to keep it the same. And we're going to focus primarily on the coefficients, the numbers in front of the radical. And that's what we're going to add and subtract. So this first example, the final answer would be radical 5. We wouldn't have to put one radical 5 because as like a variable, radical 5 represents 1. So 1 radical 5 is the same as radical 5. All right, so we go over to our second example now, and those two rules are already true. We know that the root, also known as the index, right, is 2. When it's not written, we know it's 2. Same number under the radical. So now what I'm going to do is focus on combining those two numbers in front of the radical. So my answer should be 4 radical 6, right? And then also, the last thing I did somewhat forget was, hey, if those numbers under the radical cannot be broken down anymore as well. And our third example is going to show you exactly what I mean by that. So when we move on to our third example, let's write this bad boy out. We have 2 radical 8 plus 4 radical 96, and we're going to subtract radical 24. So when we break down radicals, guys, we have to know our perfect squares. So let's just slide out to the side, right? So let's say 4, that's a perfect square. Square root is 2. Let's say 9, its square root is 3. 16, its square root is 4, and so on. 25, 36, 49, and so on, right? So we're trying to divide using perfect squares. And when it's a perfect square, we take its square root. So when I look at this first example, right, we could break down radical 8 by 4 times radical 2. And then we're going to make sure we bring that outside 2 down as well. And what we realize is that that 4 is a perfect square, right? So we simplify it. So now the problem turns into 2, and let's scroll up a little bit more. 2 times 2 times radical 2. So what does that give us? That gives us 4 radical 2. All right. So we've broken down that first radical. We're going to now go ahead and go to the next one. So our next radical is a little bit larger. So we have to really know our factors, what numbers we could break 96 down. And remember, we're focusing on perfect squares. Okay. So 96, we could use, I believe, 16 multiplied by 6, right? So radical 16 times 6. Don't forget to bring down that leading term, right? Or that coefficient, I should say. So just like the last problem, we're going to look and see if we could break down any of our radicals, and we can. 16, right, is a perfect square, and it's going to change into 4. So I bring this problem down, right? We have 4 times radical 6. So once we clean this up now, we're going to get an answer of 16 radical 6. So we pause right here and we say to ourselves, well, Mr. Peters, what's going on? You taught me those two rules about the index being the same. And then now I know the number under the radical has to be the same. But we broke these two radicals down first, and none of them are the same. Sometimes it happens like that, guys. Let's see what we could do with radical 24. Okay, so we go to radical 24, right? And remember, there's a subtraction sign out in front, so please don't forget that. So when we try to break this down, a lot of students want to use 12 and 2. And you could use 12 and 2, but then you have to break it down to break 12 down again with 4 and 3. So my best bet is to try to only simplify one time if you can, or the least amount of times. So I'm going to use radical 4 times radical 6, right? Because 4 is a perfect square. And once we do that, we're going to notice that, like I said, we have a perfect square of 4. So we simplify this now, and we're going to get 2 times radical 6. And let's just bring this down some more. I'm sorry, didn't bring it down enough. All right. So now we're going to focus on this in red, what I boxed in red, I should say. So we notice that now we do have more than one term with the same radical, right? With the same number under the radical. So I look and I'm noticing, hey, we have radical 6 here and radical 6 here. So how do we clean this problem up and finish it off? I got you right here. And hey, if you guys are enjoying this video, you found it helpful, leave a comment down below. Let us know that you guys are enjoying our videos. Smash the like button for us. We really would appreciate it. Trying to deliver the best and easiest math content for you. All right. So what I'm going to do is I'm going to keep 4 radical 2 the same because there's nothing else to add it with. There's no other radical 2's. So we have 4 radical 2, and I did switch to blue now, guys. My bad. Love blue. And our last step now is to treat our similar radicals, right? They're going to be like a variable, so it stays the same. Radical sticks will just stay the same. And we're going to do 16 minus 2. So our final answer for this problem should be 4 radical 2 plus 14 radical 6. Thank you guys for joining us our video today. We really hope you found this video helpful on adding and combining radicals. Just remember, guys, the conditions that have to be true for us to add. If we do not have the same roots, right? If we have something like the square root of 2, and I'm sorry, let's do the cube root of 2 plus the square root of 2. We could not do that, guys, because one has a cube root and the other one is a square root. All right. Even if they did have the same number under the radical, guys, it has to still have the same root. So only radical 5 plus radical 5 could we add. So thank you guys for joining me today. This is Algebra 1 with Mr. Peters. Hope you find this video helpful. Subscribe down below for us and join us next time when we break down more topics in Algebra 1 for you all. Thank you.